Dear students, I am Jamaluddin, your mathematics teacher. I think that you have been attending online classes regularly. Today, I would like to display a presentation in front of you just to support the concepts that you have obtained through online classes from the chapter Arithmetic sequence. And so my presentation is on arithmetic sequence. I think that this presentation takes only some 20 to 25 minutes. You should be very attentive in this online class, in this presentation, and after having watched this, you must respond whether this class is effective or not, like that. Okay, and I welcome you all to this presentation. Let us start the first chapter, arithmetic sequence. And so you know what is an arithmetic sequence. Recall, what is arithmetic sequence? Okay, it is an arrangement of numbers started by a number and a fixed number is added repeatedly. For an example, let us take an example of an arithmetic sequence. Let the first number is 5, or the first term is 5, and we add 6 with that 5. Therefore, 5 plus 6 is equal to 11 is the second number. That 11 plus 6 is equal to 17 is the third number. You see, 5, 11, 17 are the numbers written here. And first number 5 is called the first term. 11, second number, second term. The numbers written in an arithmetic sequence are called the terms of the sequence. And so 5 and 11 differ by 6. 11 and 7 differ by 6. That means in an arithmetic sequence, adjacent terms differ by the same value. That difference is called common difference, because the difference is common. That difference can be found by subtracting any term from the just succeeding term. Here 5 is a term, the just succeeding term is 11. By subtracting 5 from this 11, we will get 6. That is 11 minus 5 is equal to 6. Like that, 17 minus 11 is equal to 6. That is, common difference of an arithmetic sequence is that value obtained by subtracting a term from the immediate succeeding term. I think that you have obtained what is common difference. Here the first term is 5 and the common difference is 11 minus 5, or 17 minus 11, it is 6. Okay, let us view some examples of arithmetic sequences. For an example, counting numbers. Counting numbers mean numbers used for counting, that is 1, 2, 3, etc. Another name for that is natural numbers. It is an arithmetic sequence. You see, the difference, the common difference is 1. Because if we take any two adjacent term, the difference between them is 1. The common difference is 1. Let us take even natural numbers. Even natural numbers, 2, 4, 6, 8, like that. Okay, there the difference you can see. 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2. There the common difference is 2. Okay, now let us make another example. For an example, we start by a number 9. And if we add, let us start by a number 3, and if the common difference is 6, 3 plus 6 gives 9, 9 plus 6 gives 15, 15 plus gives 21, like that. Let us form such an arithmetic sequence, 3, 9, 15, then the common difference is 6. Okay, 9 minus 3 will be 6, 15 minus 9 is equal to 6. Okay, now let us take this example, 25, 22, 19. What is the common difference here? 22 minus 25, that is minus 3. Here the number added is a negative number, so that the result will be decreasing. You see, 25 plus minus 3 is 22. 22 plus minus 3 is 19, and so the common difference is here negative. So the added number is negative, so that the result will be a decreasing sequence. Here 22 minus 25 is common difference, that is minus 3. 19 minus 22, that is also common difference, minus 3. Okay, now you see how the arithmetic sequences are formed. We need to get a starting number and a common difference. Repeatedly add that common differences to the terms to get the next term. Let us start let us form such an arithmetic sequence. Let us take for an example an arithmetic sequence with the first term 4 and a common difference 6. Let us take an arithmetic sequence. Let its first term be 4 and a common difference be 6. Therefore, the first term 4. To get the second term, we have to add 6. 4 plus 6, 10. 10 minus 4 will be 6 then. Okay. Then to get the next term, 10 plus 6, 16. 16 plus 6, 22 and so on. Okay. Now we get how an arithmetic sequence is to be written. One more example. It started by 5 and the common difference is 7. Therefore, first term 5, second term 5 plus 7, 12, 12 plus 7, 19, like that. Okay. One more example. Let us start by 10 and the common difference be minus 4. Therefore, what if it will be the first term 10 and common difference minus 4. We will start by first 10. Then the second one is 10 plus minus 4. The effect will be 10 minus 4 will be 6. The next 6 plus minus 4, it will be 6 minus 4 will be 2. Okay, what will be next? Imagine. Tell me. 2 plus minus 4 or 2 minus 4, it will be minus 2 and so on. Okay, now we have found many arithmetic sequences. If it's the first term and common differences given, we are able to write the terms of the arithmetic sequence. Now let us make an algebraic form. Let us discuss about the algebraic form of an arithmetic sequence. Okay. Now let us take an example. Consider an arithmetic sequence with the first term 3 and common difference 5. Therefore, the sequence will be 3 plus 5, 8, 8 plus 5, 13, like that. Therefore, the sequence will be 3, 8, 13. You see, let us analyze this arithmetic sequence. How the first term, what is the first term? First term is 3. What about the common difference? 5. Now, the second term, to get the second term, we have to add with the first term the common difference. That is, second term is 3 plus 5. 3 plus 5 mean with the 3 we have to add 1 5. With the 3 we have to add 1 5. So second term is obtained. Okay. Now to get the third term, with this second term we have to add 1 more 5. Now the second term is 3 plus 1 5. To that one more 5 we added mean we get the result as 3 plus 2 5s. Okay. Now to get the fourth term, with this third term we have to add 1 more 5. Therefore, with 3 plus 2 5, when 1 more 5 is added, it will be 3 plus 3 5s. Okay. Now what about its fifth term? Fifth term will be, with this one we have to add 1 more 5. Therefore, 3 plus 4 5s. Okay. Now we see a particular pattern here. Second term is all these terms contain 3's, and the second term is 1 5. Third term is 2 5's are added. Fourth term 3 5's are added. Therefore, fifth term is 4 5's are added. Then what will be the eighth term? With 3 we have to add 7 5's. Now my question, what will be its 10th term? 10th term. Fourth 3 5's are added. Third 2 5's are added. Therefore, 10th term will be 3 plus 9 5's. With the 3 we have to add 9 5's. Okay. Now my question, if so, what will be its 25th term? 25th. With 3 we have to add 24 5's. Now my question, what will be its 50th term? 50th term. With 3 we have to add 49 5's. 50th term we have to add with 3 49 5's. Now my question, what will be its nth term? Nth term is just a term as like we tell some 15th, 14th, 20th, like that. Nth term as like we tell 50th term. It is 50th term 49 5's. 10th term 9 5's. Therefore, what will be its nth term? With 3. Okay, tell me, with 3 we have to add n minus 1 5's. Okay, this one can be simplified. 3 plus n minus 1 5 can be written as 3 plus 5n minus 5. 5n is written first. This 3 minus 5 when written it will be minus 2. Therefore it will be 5n minus 2. Now we see that this one is the algebraic form or nth term of the arithmetic sequence. This one represents 50th term, first term, second term, third term. If this one nth term mean it can be the first term. We need only to substitute n by 1. 5 into 1, 5 minus 2 will be 3 is the first term. Then to get the second term, 2 into 5, 10 minus 2, 8 is the second term. To get the third term, substitute n by 3, 3 into 5, 15 minus 2 will be 13 is the third term, like that. Okay, let us take another example of to form general form of an arithmetic sequence. Consider an arithmetic sequence with the first term 7 and a common difference 3. When the first term is 7, the common difference is 3, it will be 7, 10, 13, like that. Okay, now let us make the pattern as we have formed in the former case. What about its second term? Second term is 7 plus 1 common difference, that is 7 plus that value to be added, it is 3. Therefore it is 7 plus 1, 3. Third term is with this one we have to add one more 3. Therefore 7 plus 1, 3 plus 3 gives 7 plus 2, 3s. Then fourth term is 7 plus 3, 3s. And so my question, what will be its 10th term? It will be 7 plus 9, 3s. Now what will be its 15th term? Okay, let us write the 15th term. What is its 15th term? 15th term is 7 plus 14, 3s. In this way, what about its 20th term? It will be 7 plus 19, 3. Let us write its 25th term. 25th term will be 7 plus 24, 3. Okay, its 25th term will be 7 plus 24, 3. Now my question, what will be its nth term? Nth term will be 7 plus n minus 1, 3s. On simplifying this one, it will be 7 plus 3n minus 3. Then 3n is written first. Then 7 minus 3 will be 4. Therefore 3n plus 7 minus 3 means 3n plus 4. It will be 3n plus 4. The nth term of this arithmetic sequence is 3n plus 4. Let us find one more arithmetic sequence, that it be started by a decimal number half. Okay, let us take one more example. An arithmetic sequence is started by half. Let the common difference be 2. Therefore the arithmetic sequence will be half. Common difference 2 means the second term is 2 and half. 2 and half plus 2 will be 4 and half. 4 and half plus 2 will be 6 and half, like that. Okay, that is 0.5, 2.5, 4.5, etc., like that. Okay, what is its nth term? To find out its nth term, what about its first term is 0.5. The common difference is 2.5 minus 0.5 gives 2. That is common difference is 2. Then the nth term is with the first term 0.5, we have to add n minus 1 common difference. Here the common difference is 2. Therefore n minus 1, 2 is to be added with the first term 0.5. Therefore nth term is with the first term 0.5. We have to add n minus 1 common difference with the first term. On reducing this one, it will be 0.5 plus 2n minus 2. 0.5 plus 2n minus 2. Therefore 2n is written first. It is 2n minus 1.5. Okay, let us take one more example. Let it be the multiples of 4. Okay, here nth term is formulated. Let us take one more example. Multiples of 4 started by 4 and a common difference is multiples of 4 mean there the common difference is also 4. Therefore the sequence will be 4, 8, 12, 16, like that. Okay, let us take that one. It's nth term. Here we are going to think about the nth term. Nth term is we have to add with the first term 4, n minus 1 times common difference 4, that is 4 plus n minus 1, 4. Okay, on simplifying this will be 4 plus 4n minus 4. 4 and minus 4 on cancellation, there is left 4n. As in the other cases, we have formulated nth terms. Here also we have formulated the nth term of this arithmetic sequence. Okay, now let us tabulate all the arithmetic sequences that we have been discussing and their nth terms in two columns, and let us observe is there any speciality for the nth term. Okay, here the sequences are here written at this side and their nth terms are written at this side. Okay, first of all, the sequence was 7, 10, 13, etc. and its nth term is 3n plus 4. Now the another one was 3, 8, 13, like that. Its nth term is obtained as 5n minus 2. Then we have taken the case of multiples of 4. At that time it is 4, 8, 12, like that. Its common difference is 4. At that time we have obtained its nth term 4n. That 4n can be written as here 4n plus 0 to keep with a particular style as the other nth terms has come, and so it is 4n plus 0. Then another one was there 0.5, 2.5, 4.5, like that. Its nth term is 2n minus 1.5, that is 2n minus 1.5. Okay, now just observe the nth terms of all these sequences. They are all in the form of some number into n plus another number. 5n plus minus 2, 4n plus 0, 2n plus minus 1.5. All the nth terms of these arithmetic sequences are come in a particular form. It is in the form of a n plus b. Let us check this one. Is this speciality is there throughout? For this, let us take the general arithmetic sequence. In order to consider, in order to prove this case is there throughout, let us take the general arithmetic sequence. An arithmetic sequence with the first term a and a common difference d. This tells this one is not a number, is only variable, so that this one is the case of all arithmetic sequences. Okay, the first term is a and the common difference is d, and so what about is its second term? Its second term is a plus d. What about its third term? A plus d mean a plus 2d's. Third term is a plus 2d's. Okay, therefore the sequence is a, the second term a plus 1d, the third term is a plus 2d's, the fourth term is a plus 3d, fifth is a plus 4d, then the nth term is a plus n minus 1d. Okay, on reducing this one, a plus dn minus d, a plus d into n minus d. Then dn is written first, then the other will be a minus d. dn is written first, therefore dn plus a minus d. Just to view this one is dn is some number into n, that is it is in the form of an plus b. This a minus d will be a number that can be denoted by b. This d is substituted by a for convenience and a for style. It will be in the form of an plus b, where d is nothing, or this a is nothing but d, and this b is a minus d. Okay, now we see all the arithmetic sequence get its nth term in the form of an plus b. Okay, by this our presentation is over. You can write the notes from this much discussion, and you can see the what is arithmetic sequence. Okay, you can write the notes what is arithmetic sequence. I have explained to you arithmetic sequence is the arrangement of numbers started by a number and a fixed number is repeatedly added to get the succeeding terms. Okay, what is the common difference? It is the number occupied obtained by subtracting any term from the immediate succeeding term. What is the nth term of an arithmetic sequence? And what will be its general form? How will be the nth term of an arithmetic sequence? All these are explained in the notes that you have to write down this note. You can pause the video and write down the notes. Okay, now from this much discussion, let us have some questions. Here I have displayed the question, and you have to pause video and write down these questions and answer it. Okay, and I expect that you will answer all these questions, and you must, after having done these much questions, you must respond. You must tell me whether this presentation is effective for you. Is there any use by giving such a presentation in front of you that I expect from your side? Okay, and thanks for watching.